Hello dear students, myself Ganga Bhosle, your statistics teacher. In previous lectures, we have learned about binomial distribution, Poisson distribution. Okay, and today we are going to learn third one, that is normal distribution. This is the probability curve is the normal curve, and this curve is the important probability curve. The probability function related to this normal curve is called normal probability function, and the probability distribution is defined by it is called normal probability distribution. The normal distribution can be derived from the binomial distribution if the number of trial n is made to approach infinity. Okay, and this is our formula for normal distribution, that is this normal distribution is given by f of x is equal to gamma is equal to f of x is equal to y, which is coordinate of y coordinate of a point on the curve, and this is given by the formula 1 upon sigma under root 2 pi into e raised to minus 1 by 2 into x minus m divided by sigma its whole bracket square, where minus infinity is less than x is less than infinity. Minus infinity is less than m is less than infinity, and the value of sigma is greater than 0. And here capital Y is the coordinate or y coordinate of a point on the curve. Then x is abscissa or x coordinate of a point on the curve, m is mean of x, sigma that is standard deviation of x, pi is constant, and the value of pi is 3.1416 approximately. Then E is a constant, and the value of E is 2.7183 approximately. In particular, when that is mean m is equal to 0 and standard deviation is equal to 1, then this normal distribution becomes, this is our y, which is equal to one upon sigma into under root 2 pi into e raised to minus 1 by 2 into x minus m divided by sigma its bracket square. Here the value of m is 0 and standard deviation, that is sigma, which is equal to 1. Then this becomes 1 upon 1 into under root 2 pi into e raised to minus 1 by 2 into the value of m is 0. So here it becomes x minus 0, then sigma, that is 1, its square, which is equal to 1 upon under root 2 pi into e raised to minus 1 by 2 x square. Okay, here the value of sigma is 1. So it becomes 1 upon under root 2 pi into e raised to minus 1 by 2 x square. Okay, now assumptions under the normal distribution. There are 3 assumptions. First one, independent causes, second, multiple causes, and third is symmetrical. The causal forces are numerous and all causes are of approximately equal importance. The deviations from mean on either side is equal in number and size. Now, importance of the normal distribution are as below. First one is universality. It is an universal distribution because except certain conditions almost in all nature of frequency distribution is normal. Second one is study of natural phenomenon. Almost all natural phenomenon possesses the features of normal distribution such as length of leaves of a tree, height of human being, etc. Now third one, determination of limits of population value. This property states that in the central limit theorem that we can estimate the upper and lower limits within which a value of population will occur. Then SQC, that is statistical quality control. This is our very helpful for statistical quality control. Then conformity of sampling distribution. Almost all the exact sampling distribution, that is for example student distribution, Fisher's distribution, conform to normal distribution. Now properties of normal distribution. The properties of the normal curve are same as the properties of the normal distribution. These are as below. The equation of normal probability distribution with mean m and standard deviation sigma is given by this formula. F of x is equal to 1 upon sigma into under root 2 pi into e raised to minus 1 by 2 into x minus m divided by sigma, its bracket square, for minus infinity is less than x is less than infinity. That is, the value x lies between minus infinity to plus infinity. Then first important property of normal distribution is, the curve of normal distribution is, this is like bell shaped, okay, from this. This is our bell shaped curve and symmetrical about the x is equal to m. That is, this is our center and this is our also mean, that is m, which is x is equal to m, and this one is our up to plus infinity, that is from x is equal to m, from this side x is equal to m. On RHS there are only positive numbers, that is plus 1, 2 up to infinity, and from LHS x is equal to m, there are negative values, that is minus 1, minus 2 up to minus infinity. Okay, that is here there is plus 1, plus 2 up to infinity, and here minus 1, minus 2 up to minus infinity. Okay, due to, now second, due to symmetry, mean, median and mode are equal, that is mean is equal to median is equal to mode, which is equal to m, which is equal to mu. Okay, now next, because of symmetry, the first and third quartiles, this is our quartiles, that is this is represented by q, first quartile, that is q1, then third quartile, which is represented by q3, and we can find out q1 and q3 from mean and standard deviation. That is, this is our important formula for obtaining the value of q1, and this is the formula for q3, that is q1 is equal to m minus 2 by 3 sigma and q3 is equal to m plus 2 by 3 sigma. Then quartile deviation, that is quartile deviation is q dot d, and this is given by the formula qd, that is q dot d is given by 2 by 3 sigma. Okay, q1 is given by the formula q1 is equal to m minus 2 by 3 sigma, q3 which is given by by the formula q3 is equal to m plus 2 by 3 sigma, and quartile deviation is given by the formula 2 by 3 sigma. Okay, then mean deviation, that is m dot d, mean deviation is given by the formula 4 by 5 sigma. Okay, here since f of x is the probability, it cannot be negative. Then additive property, the sum of independent normal variables is also a normal variable. The area under the normal curve is distributed as follows. First one, the area between x is equal to m minus sigma and x is equal to m plus sigma is 68.27. Now, this is our bell-shaped normal distribution curve, okay, and this one. Now, here mu is our mean, okay. Now, this line represent mu plus sigma, then this line represent mu plus 2 sigma, then mu plus 3 sigma, okay. Now, this is our mu minus sigma, then this one is our mu minus 2 sigma, and this is our mu minus 3 sigma, okay. Now, for this area, that is, just a minute, from mu minus sigma to mu plus sigma, this area is our 68.27%, okay. Now, this is m minus sigma. Mu is nothing but our mean, which is represented by m, that is, this is our m plus sigma, and this is our m minus sigma, that is, m minus sigma is less than x is less than m plus sigma, that is, the value of x lies between m minus sigma to m plus sigma, and this area shows the area is between x minus sigma to x plus sigma, and this is our 0.6827, okay. Now, the area between from m minus 2 sigma to m plus 2 sigma, that is this area up to this, that is up to mu plus 2 sigma, and this area is our 0.9545. Then from m minus 3 sigma to m plus 3 sigma, this area is our 0.9973, okay. Now, the area between x is equal to minus sigma and the area between x is equal to minus infinity and x is equal to infinity is 100%. That is, p of minus infinity is less than x is less than minus infinity is our 1. Hence, p of, that is probability of 0 less than x less than infinity is obviously 0.5. This area property will be given in this following figure. Okay, this is our normal distribution bell curve, and this is our area represented from m minus sigma to m plus sigma, m minus 2 sigma to m plus 2 sigma, and this is whole area shows m minus 3 sigma to m plus 3 sigma. This is our 0.9973. Okay. Now, example number 1, that is, for a normal distribution, the lower quartile is 70 and the standard deviation is 15. Find first median, second limits of central 50% items, third mean deviation. Here we have given that for a normal distribution the lower quartile is 70, that is, first we write down in the solution given lower quartile, that is Q1, which is equal to 70, and the standard deviation, which represented by sigma, which is equal to 15. Okay. Now we find out first median. For the normal distribution, Q1 is equal to, what is the formula for Q1? That is m minus 2 by 3 sigma. Now we know that the value of Q1, that is 70, which is equal to m. Here we have to find out m. So we write here m as it is. Then m minus 2 by 3 into sigma, that is 15. Then 2 by 3 into sigma, 15 becomes 3 5s are 15. So here we get only 2 into 5, which is equal to 10. So here we get 70 is equal to m minus 10. Which therefore 70, when we put out the value minus 10 from RHS to LHS, it becomes plus 10, which is equal to m. So here we get m is equal to 70 plus 10, which is equal to 80. M is equal to 80. But we know that for normal distribution, mean is equal to median is equal to mode. So here we have median is equal to also 80. First we write, but for normal distribution, mean is equal to median, which is equal to mode. So therefore here we get median is equal to 80. Okay. Now second, here we have to find out limits of central 50% items. Central 50% items which lie between Q1 and Q3. This lies between Q1 and Q3. But here we know the value of Q1, which is 70. But we don't know the value of Q3. Therefore, we have to first find out the value of Q3. And this is given by the formula m plus 2 by 3 sigma. Okay, which is equal to, the value of m is 80 plus 2 by 3 into 15. Then 80 plus 2 by 3 into 15 becomes 10. So here we get 80 plus 10, which is equal to 90. So here we get Q1 is equal to 70, Q3 is equal to 90. Okay. So hence central 50% items, lies between 70 and 90, that is between the value of Q1 and Q3, 70 and 90. Okay. Then here we have to find out third, mean deviation, that is m dot d. And for this we know the formula for m dot d, that is mean deviation, which is equal to 4 by 5 sigma, which is equal to 4 upon 5. The value of sigma is 15. Then this becomes 5 into 15 divided by 5 is 3. 4 into 3 which is equal to 12. So here we get m dot d, that is mean deviation is 12. Okay. Here in this example, for normal distribution we are given that the value of quartile, lower quartile, that is Q1 is 70 and standard deviation is 15, that is sigma, and we have to find out median, limits of central 50% items and mean deviation. And for this, first we have find out mean, that is m, and for normal distribution mean is equal to median is equal to mode. So obviously here we get median is equal to 80. Then limits of central 50% items, that is Q1 and Q3. Here we know the value of Q1 70, and from this equation, from this formula we find out the value of Q3, that is 90. And last one, m dot d, that is mean deviation, which is given by the formula 4 by 5 sigma, and when we calculate this we get mean deviation md is equal to 12. Then next example, example number 2. The mean and standard deviation of normal variate are 50 and 18 respectively. Find the first and third quartiles of the distribution and also find QD, that is quartile deviation, and MD, that is mean deviation. In this example, we are given that mean is 50 and standard deviation, that is sigma, is 18. And here we have to first find out the value of Q1 first quartile, Q3 that is third quartile, and here also find out QD and MD, that is quartile deviation and mean deviation. First we write down the given values. Given m is equal to, that is mean, which is given by 50, standard deviation, that is sigma, which is equal to 18. Then we write down formula for Q1, that is m minus 2 by 3 into sigma, which is equal to 50 minus 2 by 3 into the value of sigma is 18, which is equal to 50 minus. When we divide 18 by 3, here we get 6. Then 2 into 6, which is equal to 12. So here we get 50 minus 12, which is equal to 38. And here we find out Q3, which is equal to m plus 2 by 3 into sigma. In same, on page number 154, in this example, print Q2, that is Q2 is equal to m plus 2 by 3 sigma, but there is Q3 is equal to m plus 2 by 3 sigma, which is equal to m, that is 50 plus 2 by 3 into the value of sigma is 18, which is equal to 50 plus 12, which is equal to 62. Then we have to find out QD, that is quartile deviation, which is equal to 2 by 3 sigma, which is equal to 2 by 3 into the value of sigma is 18. That is, here we get 12. And mean deviation, that is m dot d, which is given by the formula 4 by 5 sigma, which is equal to 4 by 5 into 18, which is equal to, when we multiply 4 into 18, here we get 72. 18 4s are 72 divided by 5, which is equal to, when we divide 72 by 5, we get 14.4. That is, Q dot D is equal to Q dot D is equal to 12 and M dot D, that is mean deviation, is 14.4. Okay. I hope all of you understood normal distribution, their properties and their respective examples. Okay. Thank you.